Have you ever wondered what happens inside your body when you eat a meal? How does your body know when it has enough nutrients, and what happens when this process goes awry, leading to insulin resistance? Well, you've come to the right place. I'm Maurice, your guide through this complex maze of cellular events happening within us. Today we're going to delve into the intricate world of nutrient-sensing pathways and insulin resistance. This is part 71 of our comprehensive series, and we're about to embark on a fascinating journey. Before we begin, please take a moment to like this video, subscribe to our channel, and leave a comment sharing your thoughts or experiences. Your engagement helps us reach more people with this valuable information. Understanding the inner workings of our bodies can be like trying to solve a giant jigsaw puzzle. Each piece represents a different aspect of our physiology, and nutrient-sensing pathways and insulin resistance are two crucial pieces of this puzzle. Nutrient-sensing pathways are like the body's internal food detectives, always on the lookout for nutrients like glucose, amino acids, and fatty acids. They help our cells understand when there's plenty of food around, or when it's time to hunker down and conserve energy. On the other hand, insulin resistance is when our cells start ignoring the signals from insulin, a hormone that helps regulate our blood sugar levels. It's like when someone keeps talking and you've heard them so much that you start tuning them out. But in this case, it's not harmless background noise. It's a critical health issue that can lead to problems like type 2 diabetes and heart disease. These two processes, nutrient sensing and insulin resistance, are intricately interconnected. They form a complex dance of signals and responses that keep our bodies running smoothly. But when they get out of sync, it can lead to health issues. By the end of this video, you'll have a better understanding of these complex processes and how they affect your health. So, let's dive in and explore the fascinating world of nutrient-sensing pathways and insulin resistance. Before we dive deep, let's first get our basics right. What exactly are nutrient-sensing pathways and insulin resistance? Well, these are two critical components of our metabolic machinery. Nutrient-sensing pathways are essentially the body's food detectives. They're cellular mechanisms that detect and respond to nutrients in our bodies, like glucose, amino acids, and fatty acids. Imagine this. You're at a buffet and your plate is full of different types of food. Your nutrient-sensing pathways are like the food critic in your body, examining each dish, deciding how to best use the ingredients, and sending out signals based on what they find. On the other side of the equation, we have insulin resistance. Now, insulin is a hormone that acts like a key, opening the doors of our cells so that glucose can enter. But what happens when the doors get a bit rusty and don't open properly, even when the key is turned? That's insulin resistance. In this scenario, the cells in your body don't respond effectively to insulin. They struggle to let glucose in, causing it to build up in the bloodstream. This can lead to various health problems, including type 2 diabetes and heart disease. So, nutrient-sensing pathways and insulin resistance are like two dancers in the intricate ballet of our metabolism. They must move together in harmony for our bodies to function optimally. When one dancer falters, the performance suffers, and health issues can arise. Now that we understand the roles and importance of nutrient-sensing pathways and insulin resistance, we're ready to explore the fascinating interplay between these two. Now that we have a basic understanding, let's look at how these two interact. Wondering how nutrient-sensing pathways and insulin resistance are linked? Let's explore 10 ways these systems interact. First up, we have the mTOR pathway. This pathway is like a security guard keeping an eye out for amino acids. When it's on high alert all the time, it can contribute to insulin resistance. Next, let's talk about AMPK signaling. Think of it as an energy detective, improving insulin sensitivity when it's on the case. Thirdly, we have the sirtuins. These nutrient sensors are like chameleons, influencing insulin sensitivity in various ways. Fourth on our list is the GCN2 pathway. This amino acid sensor is like a stress manager, affecting insulin sensitivity through its stress response pathways. At number 5, we have TREP. This carbohydrate-responsive element-binding protein is a master of disguise, influencing both lipid metabolism and insulin sensitivity. Moving on to number 6, we have the PPR pathways. These nuclear receptors are fatty acid detectives, impacting insulin sensitivity based on their findings. 7th is insulin-like growth factor signaling. This pathway interacts with insulin signaling like a dance partner, affecting insulin sensitivity with its moves. 8th, we have FGF21 signaling. This hormone is like a traffic cop in metabolic regulation, influencing insulin sensitivity based on its signals. Ninth on our list is hypothalamic nutrient sensing. The brain's ability to sense nutrients is like the captain of a ship, affecting insulin sensitivity throughout the whole body. Last but not least, at number 10, we have gut nutrient sensing. This nutrient detection in the intestines influences systemic insulin sensitivity like a gatekeeper, deciding what gets in and what stays out. Understanding these connections is the first step towards managing and preventing insulin resistance. And remember, knowledge is power. The more you understand your body, the better you can support it. So let's continue this journey of discovery together. While the interplay between nutrient sensing pathways and insulin resistance may seem complex, there are ways to manage and prevent these issues. Let's explore some strategies. First up, caloric restriction. By moderately reducing calorie intake, we can improve both nutrient sensing and insulin sensitivity. However, while it can potentially offer longevity benefits, maintaining a lower calorie intake can be a challenge. Next, we have time-restricted eating. This involves consuming all your meals within a certain time frame each day. This approach can help reset nutrient sensing pathways and is flexible enough to suit different lifestyles. But remember, it may not be suitable for everyone. High-intensity interval training, or HIIT, is another powerful tool. This form of exercise can activate beneficial nutrient sensing pathways. It's time-efficient and effective, but it might be too intense for some. The ketogenic diet, a low-carb, high-fat diet, can also alter nutrient sensing. It's been effective for some, but it can be restrictive and may not suit everyone. Then we have protein cycling. This involves varying your protein intake, which can influence amino acid sensing pathways. It may have metabolic benefits, but it requires careful planning and may not be suitable for all. Cold exposure is another interesting technique. Brief exposure to cold may activate certain nutrient sensing pathways. It's potentially effective and inexpensive, but it can be uncomfortable and may not be suitable for everyone. Lastly, targeted supplementation with compounds like resveratrol or berberine can also help. However, it's important to consult with a healthcare provider before starting any supplement regimen. Remember, a healthy body is a result of balanced nutrition, regular exercise, and mindful living. Each of these strategies offers a way to better manage nutrient sensing and insulin resistance, but it's crucial to find what works best for you and your unique body. Your health is a journey, not a destination, and it's about making sustainable changes that you can maintain in the long run. We've come a long way in understanding nutrient sensing pathways and insulin resistance, haven't we? We've explored how these intricate systems interact, influencing our overall health. From the mTOR pathway's role in amino acid sensing, to the impact of hypothalamic and gut nutrient sensing on insulin sensitivity, we've delved into the complexity of our metabolism. We've also discussed practical steps to manage and prevent insulin resistance. Whether it's through caloric restriction, time-restricted eating, or high-intensity interval training, we have the power to influence our health. Even dietary changes like a ketogenic diet or protein cycling can make a difference, as can targeted supplementation and cold exposure. The journey to health is a continuous process of learning and implementing, and understanding nutrient sensing pathways and insulin resistance is a significant part of that journey. As we wrap up, I want to emphasize the importance of understanding the interconnected nature of our metabolic processes. By recognizing how nutrient sensing pathways interact with insulin resistance, we can take a more holistic approach to metabolic health. Before we conclude, I must provide a brief disclaimer. The information in this video is for educational and entertainment purposes only. Any health-related decisions should be discussed with a licensed physician. Your individual situation may require specific medical attention, and it's crucial to seek professional advice for personalized care. Thank you for joining me in the Victory Education Lounge. If you found this information helpful, please remember to like, subscribe, and share your thoughts in the comments. Your experiences and questions can help others on their health journey. Until next time, this is Maurice, wishing you health, vitality, and optimal nutrient sensing.